What's up? I'm Vin, and today I want to show how to use the law of sines to find the missing side of a triangle. So here's the formula we're going to need, and let's get started. So first up here we have triangle ABC, and we're given two angles and a side, and we want to find the measure of side AC and side AB, and we're going to round to the nearest hundredth. So for questions like this, I highly recommend that you draw out a triangle if they don't give you one. So we have triangle ABC, and we label the angles with capital letters, and the measure of angle A is 30 degrees. So we'll label this angle here. Then we have the measure of angle B is 65 degrees. So we could label this angle here. And we're told the length of side BC is 10 units long. So this is what we have here. And we want to find the measure. First, we'll find the measure of side AC, which is this side over here. And notice this side is across from angle B. So we'll label this side with a lowercase b. And then the side across from angle C, we'll label with a lowercase c. And now when we have our formula here, we have sine of angle A over side A is equal to sine of angle B over side B, and that's going to be equal to sine of angle C over side C. But we only need to choose two pieces here. So if we're looking for side AC first, notice that has side B. So we're going to use the first two pieces here to set this up. So we're going to have sine of, and the angle we're going to use for A is 30 degrees because that's the measure of angle A. So we have sine of 30 degrees over side A is always going to be across from angle A. So that's going to be over 10 equals, and now we have sine of the measure of angle B is 65 degrees. And this is over the measure of side B we don't know. So we're just going to leave that as lowercase b. So now we'll just do a little bit of algebra here. We're going to cross multiply. And this is going to give us B times sine of 30 degrees. And that's going to be equal to 10 times sine of 65 degrees. So now to solve for B, we're just going to divide both sides by sine of 30 degrees. And now the rest of this, we're just going to type in the calculator. So let's go ahead and type this in. We're going to press alpha y equals enter to pull up a fraction. And we had 10. So we're just going to type this in. We have 10 and then sine of 65 degrees. And notice here that I'm in degree mode. If I'm in radians, I'm going to press mode and switch over. But so far, so good. So I have 10 sine of 65. And we're going to divide by, we said sine of 30. And for this question, we're rounding to the nearest hundredth. So let's just make sure we type in. We got 30 degrees here. So now we press enter, and we're going to round this to 18.13 since to the right here is the 6. So after we do the algebra here, sine 30 cancels out with sine 30. We're rounding to the nearest hundredth. This is going to work out to 18.13. So now the last part of this question told us to find the length of segment AB, which uses lowercase c. So now this time what we want is we're going to use this formula. We could use sine of A over side A. So we have sine of angle A over A equals, now we have sine of angle C over side C. But one thing we have to do first, we have to know what is the measure of angle C. And we have a triangle here with two angles. So to find the missing angle, we're going to subtract the sum of these two angles from 180. So we'll have 180 minus 65 plus 30 is 95. And when you subtract these, you're going to get 85. So that's the measure of angle C. So we have to do a little bit of geometry here to get that missing angle. So now what we have is we have sine of 30 degrees over the measure of side BC, or we could say side A, is 10 units. And that's going to be equal to, we have sine of the measure of angle C we found to be 85 degrees. And now we're dividing by lowercase c, and that's what we're looking for. So now, same as before, we're just going to do the algebra. So we have c times sine of 30 degrees equals, and we're going to have sine of 85 degrees times 10. So we have 10 times sine of 85 degrees. So now to solve for c, we're just going to divide both sides by sine of 30 degrees. And the rest, we're just going to punch in the calculator. Now, I could pull up a fraction again, or if I want to save time, I'm just going to scroll over to what we typed in before and press enter. And notice this time around, the only difference is that in the numerator, we're going to have 10 sine of 85. So I'm just going to swap out this 6 with an 8 and press enter here. And our missing side is going to be 19.92 units long. So we'll just show the algebra here, and we could say that C is equal to 19.92 units. Now, if we want to state the answer formally, technically they asked us to find the measure of side AB. So we could just say AB is equal to 19.92, and we could say that the measure of side AC is equal to 18.13, which is what we said before. So this is our final answer to the first question. So what we have here is we want to find the height of this tower, and we're given the measure of a few angles, and this length here is 100 feet long. So what we need to do is we're going to use some other geometric properties, and we're going to find the measure of this angle over here first, because we have a straight line. So if we do 180 minus 65, that's going to tell us the measure of this angle here, which would be 115 degrees. So we'll just write that in. We have 115 degrees over here. And now what we could do with this information, now that we know the measure of this angle and this angle, we could find the measure of this angle up top in this triangle here. So we're just going to add 115 plus 32, and that's going to give us 147. And that we're going to subtract from 180. And that's going to tell us the measure of that missing angle. And this is going to work out to 33, so we'll write it with the units here. This missing angle is 33 degrees. So now, when we're using the law of sines, the way I imagine it in my head is whatever angle I'm using, the side that goes on bottom is the one opposite of the angle. So right away when I look at this, I say sine of 33 degrees over 100, and we'll write units at the end. Just know this is 100 feet though, is equal to, and then I would have sine of 115 degrees. And I could call this side over here whatever we want. We'll just call it x. So we have sine of 115 degrees over x. And once again, the significance of setting the equation up this way is that this angle is opposite x. And the 33 degree angle is opposite the side that's 100 feet long. So now to solve for x, we're just going to cross multiply. And we'll have x times sine of 33 degrees is equal to, we'll have 100 times sine of 115 degrees. So now to solve for x, just divide both sides by sine of 33 degrees. And we're going to type this in the calculator, but just know we're not going to round to the nearest foot until the very, very end. Because right now we're solving for this, but we're going to write out the entire decimal. So we'll have x equals, so we'll just pull up another fraction. We have alpha y equals enter. And in the numerator, we're going to have 100. And then we have sine of 115 degrees. And our calculator is still in degree mode here. And now in the denominator, we're dividing by sine of 33 degrees. So we'll just make sure we have this typed in right. So this is going to be the value of x, and we're going to write all of this. So we'll say here x equals 166.4052205. So for the second part of this question, now that we know what x is, I want to focus on this big right triangle here that basically captures the entire diagram. And what we're looking to find is the height of the tower, which we'll just put a y here. So now that we found x, we could use this 32 degree angle, and if we forget the trig functions, this mnemonic helps SOHCAHTOA. That in this case we could use sine, and we could say sine of 32 degrees is equal to the ratio of the side opposite of the 32 degree angle, which if we look all the way opposite, that's going to equal y over the hypotenuse. That's what the OH stands for, opposite over hypotenuse. And our hypotenuse of the big right triangle here is in terms of x. Now, I know we already solved for what x is, but I just don't feel like rewriting that entire decimal. So what we could do with this now, if we want to solve for y, we're just going to cross multiply. And this tells us here that y is equal to x times sine of 32 degrees. So all we have to do in the calculator is multiply our previous answer by sine of 32 degrees. And that's going to tell us the height of the tower. So all we have to press here is times, and we had sine of 32 degrees. So we're just going to punch this in. And the question said to round to the nearest foot. So 88.181 is going to round to 88 feet. So we'll say y is equal to 88. And now we'll just write our answer formally. The height of the tower is 88 feet.